Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always. Excuse a strange camera angle, but I'm sitting on a little stool so that I can show you this amp here. It's a VOX AC30 TBR. TB stands for top boost, R is the reverb model, and it's the vintage version of this, made by a company called Rose Morris. If you know anything about VOX, which by the way I don't know a lot, you'll know that they have been made by lots of different companies with varying degrees of success. This is a Rose Morris version. I don't really know how good they were or what sort of quality they produced. Anyway, this amplifier has the problem which every single example of this amplifier has, and that is that the reverb transformer fails. So you get no reverb. It's a little printed circuit board mounting transformer like this, and this is rated at 1/2 watt, and the actual circuit produces 1 watt, so go figure, they all burn out. Now the trick to fixing this is to put a different reverb transformer in, one that can handle a bit more power, and unfortunately it won't go on the printed circuit board. You have to remote it to the chassis. So I've never done this before. I'm going to give it a go, and hopefully we'll be able to resurrect this amp. He also wants a complete revalve on this amp, which is hugely expensive at the moment. The valves have doubled in price. Where are we? November 2022, and this has about 374 valves in it, so it's going to cost him a real ton of money to revalve this. Anyway, let's have a quick look at the amp from the top, and it's got quite a nice cabinet, so I think you'll enjoy this. Right, I've got the chassis out. I've taken the valves out because I'm going to do a full revalve on this amp anyway, and I've put a new set of power valves in. So this is the top side, and you can see a certain amount of the printed circuit board is accessible via this cutout here. Now let's flip it over and find the offending reverb transformer. And here we are on the other side of the board. Just have a little scan along, and here's the offending item here. So this is the A262AE3E-1 little printed circuit board mounting audio transformer, and that's the one that's rated at 1/2 watt, and they put 1 watt through it, so that's why it burns out all the time. So what we're going to do is try to replace that with a chassis mounting heavier duty reverb transformer. I got mine from Mouser Electronics, and it's come through today. Here it is. So let's open it up and see what we've got inside here. I know it won't be a printed circuit board mounting thing. We're going to have to somehow, I don't know, chassis mount it somewhere. Obviously the closer we can mount it to here the better. I don't ideally want to be remoting it all the way over to here. It would be better on here somewhere, which is kind of here. But I don't know how big it is. Let's unwrap it and have a look and see how big it is. Okay, so what have we got here? A Mouser audio transformer, Mouser part number 546-125A. That's the one. It's actually a Hammond 125A transformer. Okay, we've got quite a lot of info on the side here, which I guess we're going to need. There we go. So we've got the primary and then some sort of a secondary which we can tap off on. So I'm hoping we're going to be able to find out which is the correct tap for this. An article I read online said the 16 ohm tap is the one to use, but whether we can identify that or not another matter. Right, we're definitely going to be keeping this. Oh, there we go. 8 ohm. Oh, I see. 16 ohm. No, we'll have to think about that. Right. So here we have. Right. Well, this is what we've got. This is the primary. That's okay. That's easy. And we've got all these secondaries. We've got these six possible secondaries here, and no, it means nothing to me. That's a pity. I thought that might be quite easy. Alright, well, let me just show you a quick sketch I've made. Sorry, it's a little bit kind of very crude, but I just thought you'd like to know what's going on here. So basically they use an ECC81 here to drive the reverb transformer, and here's one half of the ECC81, here's the other half of the ECC81, and you might recognise this arrangement actually. Look, you take one anode up to one side of a transformer, another anode up to the other side of the transformer, you centre tap to HT. Well, that's exactly what you do in a push-pull output of most Class AB amps. And then of course this would be going to your loudspeaker. So they've done the same thing here, except they've taken HT via an 8K2 resistor, bit of smoothing, and this is what's driving the reverb spring in a kind of push-pull arrangement on this ECC81. And then they connect the secondary off to the spring input, the thing that actually waggles the spring. So that's what's going on, and that's fairly straightforward. We don't have any problem on the primary, because all we need to do is to connect those three wires there to the primary in the correct way. Of course, make sure we have the centre tap going to the middle. No, we don't care which one of those goes to there. And there's the diagram look. So we're going to connect blue and brown to the anodes of the ECC81. We're going to connect red to the centre tap HT point, providing I can locate it on the actual amplifier. Our problem comes in impedance matching this secondary side to the spring. I'm sure some of you are looking at this and screaming at me saying, "Oh, come on, Stu, it's obvious." But I'm having a bit of a blank spot at the moment. Voice coil impedance. So that's the voice coil impedance, and that's the secondary side, I guess. Connect to 1 to 2, 1 to 4, 2 to 4, 1 to 5. Well, obviously there are a lot of different impedances you can pick up off here. You can go from 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 2 to 3, 2 to 4, 2 to 5, 2 to 6, 3 to 4, 3 to 5, 3 to 6, 4 to 5, 4 to 6, and 5 to 6. So I'm guessing that they've got all those options down here. Yes, I'm sure they have. So those are all the options of impedances. Okay, I've got it. Right, okay, that took a little while. Stop shouting at the screen. It's been a long day. Okay, so here's how I read this. Check me if you think I'm right. I'm reading this as follows. If you want a, doesn't matter, 8 ohm voice coil impedance, then if you want a primary impedance of 22,600 ohms, you pick up the 2 and 4. If you go 3 and 5, you get a primary impedance of this. If you go 4 and 6, I think I've missed it, 3 and 5, 4 and 6, you'll get a primary impedance of that. If you go between 1 and 4, you get a primary impedance of this. So basically you can choose your primary impedance depending on which of these you pick up. If you want a 16 ohm, which is what the article said, no idea if that's true or not. If you want a 16 ohm voice coil, then you'll get primary impedance of whatever this is, depending on which of the connections you pick up here. Well, I've sort of slightly misphrased that actually. A better way of stating it would be if your voice coil impedance is 16 ohms, and you connect and you pick up the secondary on 4 and 6, you will get a primary impedance of 24,000 ohms. So if your voice coil impedance is 8 ohms and you connect 1 to 4, you will get a primary impedance of 11,600 ohms. That's kind of how that's working. Now, that doesn't help us terribly well, because we don't know what primary impedance this little circuit here is hoping to see. We could, I guess, look up the old transformer. I knew this would be difficult. I've been putting off this job for days, actually, for exactly this reason. I just kind of thought this is not going to be easy, this. So basically, one thing I guess we could do is to look up this transformer here, the A262A3E1, and find out what the primary impedance is connected in this configuration, and see if that helps us. It may or may not. And also, by the way, I'm only going on one article which says, and I quote, the 16 ohm tap on this new transformer is just right for the spring that they use in this VOX. No idea if it is or not. If push comes to shove, I think what I'm going to do is just pick a medium. I'm going to assume it's right, that 16 ohms is right. No idea if it is or not. And pick a medium in sort of impedance, 15.5k or something, and then just pick off the winding 2 and 5 and see if it works. That's that absolute fallback position. Let's see if we can get any data on this transformer here. Right, I've been online for about an hour, and I thought I'd let you know the results of my research. First of all, there's nothing online that I can find out about how to replace the Reverb transformer on a VOX AC30 TBR vintage. There's nothing there at all, even though these transformers go wrong all the time. It's a pity no one seems to have done it before, or at least they have, but they haven't documented it. Right, so I've looked up the original transformer. That's the one that's in here, this one here. I've got the spec sheet on it, and it's a 1 to 6.45 turns ratio, or should I say 1 plus 1 to 6.45 plus 6.45, actually the other way around. And I think they're using it reversed, so they're driving the secondary, the high impedance side, the 6.45 side, and taking the output out on the primary, so it's like a step down transformer in this case. The secondary impedance in this configuration, in other words series wound, is 25k, so that's quite useful. The primary impedance is 600 ohms, which is, seems high to me. Seems a very high impedance to drive the spring. So then I looked up the spring, the Accutronic spring, which is a 9BC2C1B. All these letters and numbers mean something, by the way. I've got a handy chart which I look up. It's the impedance, the number of springs, the decay length, and all that sort of stuff. Anyway, let's not worry about that now. The input impedance of this spring is 200 ohms. So it looks like, at the worst case, they're using a 600 ohm impedance here to drive a 200 ohm spring. Okay, fine. Maybe I'll buy that. But what's with this, quote, the 12 ohm tap on this will work well? Sorry, beg your pardon, the 16 ohm tap on this will work well. We're looking at 600 ohms and 200 ohms here. So I don't know the answer to that. So what I'm going to do is to assume that we need a primary, let's call this our primary even though it's the secondary of this PCB mounting transformer. This primary side, it seems to want an impedance of around 25k. sort of feels about right to me, maybe with an ECC81 driving at a preamp valve as opposed to a power valve. If this was a power valve, you might look for more like 8K or something there. I have to tell you, I'm not an expert on this side of things, these transformer ratios and impedances. I know the basics, of course, but I'm far from an expert on this. Right, so 25K feels about right to me. So let's look down here and find if we can get something approaching 25K on a 16 ohm output, and here we have 24K. So I'm tempted to go out to come on 4 and 6 as my output there to drive the spring, which will give assumingly will give a, well, we don't know what it'll give, to be honest with you, because with a let's think about this a second, with a 16 ohm speaker or load, it will give 24K, but we've got, you know, a couple of hundred ohms, so to be honest with you, I have no idea, but I can't do more than that. We probably can't go too far wrong having a go with that, because we'll have, if we have a higher impedance here, the reflected impedance will be higher too, so we're not going to do any damage to anything. So I think what I might do is just lash this up on 4 and 6 and see if we can get any noise out of the spring. If we do, I might try kind of sneaking down here a bit and see if we get a better response on the spring. I can't think of anything else really that I can do there. Yeah, I mean, you watching this, you may be, you know, slapping your head in your hands and thinking it should be obvious what to do, but to be honest with you, it's not obvious to me what to do here. I would have preferred if someone had done this already and said, look, what you want to do is you know, wire up primary and come out on 2 and 5. That's just perfect for this spring or something, but we haven't done that. We haven't been able to do that. Right, now, okay, so let's put all that aside because we've got another problem. And the problem is, let me zoom out. The problem is how to get this transformer out. Unfortunately, it's not just unsolderable via our nice little hatchway here, because as you can see, it's under here. In fact, the one side of the terminals are literally just here. They're only about like that far in, so I could easily unsolder those. The other terminals are about here. Let me just quickly show you something else as well online. I got this diagram here. This was for a tube amp Doctor Reverb transformer 125A 20B, suspiciously like the one we've got here, which is the 125A. So probably not the identical thing, but if you look at this, you know, mystery upon mystery. This is a reverb drive transformer for all sorts of makes of amps, so it's not going to be too different from any reverb transformer. Notice that the primary 25K ohms, great, that's what we're looking for, nice. Secondary is 8 ohms, which is not too far off from the 16 ohms which they say we should use on the on the new one. So how that 8 ohms relates either to the 600 ohms output impedance of the PCB transformer or the 200 ohm input impedance of the spring, I don't know. Right, so what I'm going to try and do, and I don't think I can do it, I'm going to try and desolder this from the top. I don't want to take this board out if I can possibly avoid it. It's a right flipping mission. So when I tilt this up here, there's the first row of pins on the transformer, and gets those easily. The second row are just back there, look. So zoom in and show you that. There you go, you can see that quite well now. First row, second row. I think I might just about be able to get a soldering iron and of course some solder wick is what I need in there, and desolder this top side. Then I can get some, just put some wires in. Right, let's have a go at that then. So to do that, I think I'm going to want to try and balance this. And I don't know, let's see if we can desolder it. It's on the limit of possibilities. Right, we're going to use some Chemwick desolder braid and attempt to desolder these. So I'll just do one or two to see if I can do it. Obviously these front ones are easier. Never particularly easy to get something like a printed circuit board mounting transformer off a PCB at the best of times actually. That's when you've got the PCB in your sticky little hands. But this desolder braid is absolute magic stuff. Right, I need to get my eyeglass in there if I'm able to, just to see if that's worked. Looks kind of reasonably hopeful. Now, the moment of truth. Can we do the same? Yes, we can. Oh, goody goody. You know, assuming this works at all, of course, we can actually get on these, which is great news. You can still see solder on there. As I say, these are not easy to get out at the best of times. Right, I'm going to get in there with my eyeglass and see if I can see anything. The winding driving the reverb spring is there and there. So the start is there and the finish is there. And these two are not used at all. On the primary side, our primary, we would call it, these two are joined together and that goes off to HT. And then here's one side of the EC81, here's the other side of the EC81 anode. And these tracks go off up to the ECC81 anode there. Right, well what we want to do now is see if we can get this transformer out, and if there's any hope whatsoever. It'd be nice, wouldn't it? I've had a look with my eyeglass, doesn't seem to be much solder on those pins. And it doesn't really want to move. Let's see if we can give it a little bit of persuasion with a leverage. Can we get underneath it? Probably not. Right, that took a bit of desoldering and a bit of levering and a bit of chicanery, but I did actually manage to get that out top side. I did break off one pin, but it doesn't matter because it's junk anyway, so that's great. So now we're in a situation where we can tack some wires on to the various connections there, and just hang in anyway, it doesn't matter, just on the bench, our new reverb transformer, and see if we can get any sound out of the existing reverb tank. That's a job for tomorrow, quite a long job. I've got to get that, you know, soldered in somehow. I've got to put all the valves back in, get the reverb tank out and connect it up. So let's leave that now for tomorrow. It's getting a bit late, and fingers crossed we can get some noise out of the reverb tank. At least we managed to get the old transformer out without taking the board out. Okay, I'm been back on again for a couple of hours today prior to doing any filming. It's taken me a long time to sort this out. So basically what I did, this is the new transformer look, the secondary, or actually it's the primary of the transformer. So this is the step down bit. Here's where we put our signal in from the amp, and here's where we drive our reverb, spring reverb from. So the question of which tappings do we use here? So I did some tests by putting a signal in on the primary and measuring the output on the secondary, and I got the following kind of you know, step up, step down ratios. Look, between 4 and 6 I got 19 to 1 step down ratio. Every 19 volts in there gives you 1 volt out here. Between 1 and 5 I got 12 to 1, so every 12 volts you put in here you get 1 volt out here. And between 1 and 6, which I think is probably the best you can do on this because that's the whole winding look, I get 10 to 1 reduction. So this gives me some options about the signal level I get out here to drive the reverb spring for a given signal level in here. Obviously this is fixed what we're putting in here and what we get out. So it gave me some options. So I hooked it up. I'll show you what I've done in a minute, but I hooked up on a 19 to 1 4 to 6 winding. That gives me the smallest signal coming out because I didn't want to cook the input coil to the reverb. Hooked it all up, turned it on, turned up the reverb, and I could hear the reverb, but it was faint. So then I tried on 10 to 1, so that is 1 to 6, and that gives a 10 to 1, so getting almost double the signal that I was getting to drive the reverb, and the reverb is tolerable. It's not super, but it's, I think, doable, and that is the best we can get out of this transformer. We won't get any more signal out of here by taking any of these tappings. I think you'd agree the biggest signal we can get is across the whole coil. So that's what we're stuck with. Let me show you what I've done. Be a bit careful here because we have got some high voltages on here. So here's the remoted transformer. I've just got it tacked on a load of wires which I've tacked onto the board where the original transformer was, and I've just dumped it on the side here. And I've got the spring reverb here from the actual amp, so this is actually the one that's in the amp. And here we go, this is full reverb. Not too bad. If I turn it down to half, still there, down to about a third, still a bit. So that's the best we can do with this setup, I believe. So I'm going to leave it at that now, turn this off. And there you go, it's a bit crude, you can just see I've just remoted the transformer onto the bench there with a whole long length of wire. So now tacked onto where the original reverb transformer was, look. So now what I need to do is tidy this up and find a home. I'm quite pleased actually that this worked, and it didn't produce a horrible hum when I turned up the reverb with all these wires floating around. That gives me hope that I can remote this now somewhere on the chassis, not quite sure where, and these wires will be about a third the length, if that really, and I'm hopeful that we won't get a lot of horrible hum. So now I'm going to untack this from here, turn the amp off, unplug it, and then we'll turn the chassis over and see if we can find out where to put this new transformer. But just in case you're watching this and you are struggling to do this yourself, let me just be very clear what we've done here, because it's taken me quite a long time and I don't want you to have to duplicate all this. So here is our primary, so that goes to the anode of one half of the ECC81, that goes to the anode of the other half of the ECC81, that goes to HT via an 8K2 resistor. So standard push-pull arrangement, and we come out on 1 and 6 on the secondary. That's what I've done. You can do what you like, but that's what I've done. And 1 and 6 on the secondary is there's only one option, that's this here, look, 1 and 6, and I don't know, it says it's a 5,600 ohm reflected impedance with a 16 ohm load, but this isn't a 16 ohm load, this is like, I don't know, a couple of hundred ohms, so I really don't know, and it would take me too long to find out. Right, so let's see if we can remote this and get it sensibly connected in. Okay, I think I found a good place for it. We're going to put it on the side here, and the connections are literally just here. Look, that's the old transformer that I've removed, so we can keep the leads nice and short going down to here. So that's what I'll do. So that means drilling a couple of holes in the side and putting a nut and bolts through and bolting that to the side. So I'll do that off camera. You don't need to see me drill holes and bolt a transformer on. I'll rejoin you when that's been bolted in place. Right, okay, so we've managed to bolt that in there. Very neat job, and all we now need to do is to connect these wires over to the relevant bits of the original transformer. So I'll do that, and these leads are about a quarter or fifth the length they were when I remoted the transformer, so that's good in terms of pickup and hum and that sort of thing. But anyway, proof of the pudding is in eating, etc. So once we've connected these, we'll power it all up again and see if the reverb's still working. Okay, there you go. There's the transformer in, and I connected the secondary directly into the cable going off to the reverb, and it's as it was before, so that's alright. Seems to sort of not the most fantastic reverb in the world. Yeah, just found my original piece of paper, and it's 6.45 to 1 was the original turns ratio on the printed circuit board mounting transformer, and we've got like 10 to 1 on here. That's what I measured, so not quite half, but you know, if I hit that reverb tank with double that signal, I think we get a better reverb. So for my money, this transformer just about fixes this problem, but it's not ideal. It's not easy to get a reverb transformer with this push-pull primary. Most reverb transformers you get are, there's my other piece of paper, are like this tube amp doctor one here, and they are like this. Look, you know, you get primary and you get secondary. I say 99% of reverb transformers are like that, whereas our one here has this push-pull arrangement, so it needs this center-tapped primary. So I think basically this is the best of a bad job. You kind of just about get your reverb back, but it's not stunning. Hopefully it's good enough. Right, well, I've kind of spent a lot of time on this, huge amount, and obviously can't charge for it as always. I'll just have to charge a reasonable amount. And we've done a full revalve on this amp as well, so it's now kind of up to scratch. Yeah, not too bad an amp really. I'm sure you know about the VOX history. These VOX AC30s are made by everyone and their dog basically, with varying degrees of quality. So if you buy an AC30, you really have to look up which manufacturer made it. Okay, let's get the thing back together and we can wrap this one up, and to be honest with you, I'll be glad to see the back of it. Okay, well there you go. I hope you enjoyed that one. I wanted to make this video because there was absolutely nothing on the internet about changing this reverb transformer, apart from one article where I picked up the fact that that 125 reverb transformer is the correct, or is a good approximation of the existing one. So the end result was acceptable, I would say. The reverb isn't particularly stunning, and I believe that's because we are driving the reverb spring with about half the voltage that it should be driven by, and if it was driven by the full voltage you get a much more echoey reverb. But I don't know where to get a better transformer than the one I've put in. The difficulty being, as I said, it needs that center tapped primary. There are plenty of reverb transformers out there with just a single primary. This needs a center tap because it does a push-pull arrangement on the reverb send, and this is the only one available, so I think this is probably the only fix. Anyway, I hope this helps you if you are attempting to get your own AC30 TBR vintage reverb back up and running. At least this gets you out of trouble. I think we'll have a little play actually, and just you can hear it, and I believe it's acceptable, and I hope the client will find it so. He's going to come and pick it up in about half an hour. So thanks as always for watching. I'll just play a few chords to show you how the reverb sounds, and then we'll call this a wrap. Okay, here we go, amps on, we're in the normal channel, and the reverb is up to maximum. Let's just check that. Yeah, reverb is on maximum, so you can see, not stunning, but I think usable.